So in our practical exercise, we have to build Java graphical application, and to make our life easier, we will use Window Builder plugin for Eclipse, which is forward reverse engineering tool between graphical interface and Java code, which will handle it. And as usual, here this guide is for old school approach, when you need to add another entry for address from which you can download this plugin and install it. But for newer Eclipse, we may be optimists and we first can try to search it in Eclipse Marketplace. We choose Help Eclipse Marketplace. And again, here we see that it is actually available through the Eclipse Marketplace, and if it is, then we don't need to do this ceremonial approach with dealing with remote repositories, etc. And what I also see here is that for my Eclipse it's already installed. If it's not already installed for you, you install it. And then every time you use something which doesn't come as a standard with your development environment, my recommendation is to test it out with some simpler project. And again, in Eclipse, working with several projects is not hard. You can see them here as a list in the same Eclipse. In other IDEs, it is not so easy. So my recommendation is that you should have some test project here. We can delete some of previous classes. I will still leave this test.java. And to test out that this plugin works well for us, we will create new other. And here inside Window Builder, we choose Swing Designer, and it also supports SWT Designer, but I don't know much about it, so if you are curious, you have to investigate it yourself. And here you have several options. You can create new application window, new Java applet, so don't create that one. This technology is not supported anymore, at least for clients. Then JDialog means template for window, which is like dialog window, which thin border here, no minimize buttons, etc. JPanel. What is this? Automatic data binding? No idea, have not used it. But we will start with this application window. So Java application with some window here. And something like this should do. And we press finish. And if this plugin works properly for you, then this Java code is not opened with Java standard editor, but it's opened with Window Builder editor. And if it's opened with Window Builder editor, you should be able to see these two tabs for this editor, source view for it and design view for it. And this is what we want to see here to help us to generate Java code for particular application. We can put some labels there. You see here that by default it uses this north, south, east, west layout managers. So here somewhere in properties of pane, you see here what layout is put here, and you can change this layout to something different if you need, if you like. For example, from these layouts you can change it to something different. And you can customize it, and when you customize it, save it, you can switch back to source view, and you have generated code according to your changes. How does it work? Following that, of course it is Java standard application. Okay, first let's run it. Because it's runnable as a Java application, it has main method, so you run it and you see that here it is. And how this particular thing works: in main method you have this event queue invoke later and new runnable, and then body for it. So if you look on Java dots of this method, you see that it takes reference to some runnable as a parameter for it, but runnable itself is just an interface. And if you say something like this new interface here, you may be a little bit surprised, because interface in general is abstract class. And how does it work? That if you do such approach and you say new runnable, what you need to do here is to also implement it immediately. So what is happening here? We pass reference to class which implements runnable interface, and we do this implementation immediately when we are passing it. So I think it should work if you would do something like this. And then this is a much more classical approach. And then, of course, if you will do something like this, you will get compilation error, because you cannot instantiate the type runnable. So this approach, when you are allowed to do this new, is when you actually implement interface immediately after you are referring to it. And what this method does, this method starts your application window into separate Java thread. And why it is done so? Because there may be that you may have your Java application containing many windows, and it is recommended that all of these windows are working in separate thread. Then you can just easily hide one window, open another window, hide another window, open this first window, and switch like when you switch from window to window. And that's how this code, these are these design considerations what this code does. If you do not want these funny things and you want to set just simple stupid application with only one window which works only in my thread, main thread, then you can do something like this. You create new application window object, and inside this object you have private gframe object which you set it up here in this initialize method. And now it will work in absolutely the same way. Only difference is that currently now this window is working inside main thread, not in separately created thread. And this would be a typical example how you create some simple Java application without any funny things about separated threads. So it has, it is just a Java application, extends only Java object, and there's gframe inside it, what is actually shown on screen when you run it. If you start creating more complicated Java applications, which may have different windows or different screens, then you may need to put several gframes inside this application, and then you may create just gframe. And where is difference? Difference is that now this class doesn't have gframe inside it like this test application, but it is gframe itself, it extends gframe, and that means everything what you here did with this train notation, put internal property of frame to new gframe, frame set properties here, frame set properties here. So you did it with this internal object of your test application. Now your application actually is gframe, and that means you can just directly say what is content for pane for it, what is other things. You can of course add, let's say, change it to, for example, I do not know. Then you can put some components inside it. And you run it, and here is your gframe, still living inside its for gpanel you don't have this funniness, you don't have it separated thread. No, it should be, I'm not looking in proper place. Here. So again, create actually separated thread for handling this particular G-frame. Again, if you want simpler code, simpler for debugging, etc., you just set it up and make it visible into the main thread. My recommendation is that you should start dealing with separate threads only if you have several windows in your particular application. So, and I have tested that in general this plugin is working in simpler projects, and that means I can now go to actual project here in activity 16. And in this activity 16, design is already given for us. We have class color slider, and you should open it not with standard Java editor, because that will make your life a little bit harder, but you should open it with window builder editor. That will make your life easier, because then you will not need to know so much things about actual construction of different elements, because you can construct your graphical interface here in this graphical editor, and it will update your code accordingly to this graphical design here. And what you need to implement here, you have to implement this application color slider in such way that you have 3 sliders for red, green and blue components of a color, and when you slide these sliders according to their component here, the background color of this test area is changing to appropriate color according to component values of this red, green and blue colors. So if your window builder works, then adding sliders is not that hard. You choose them here from components view, and here layout is already given to you, and you can put one slider here, another slider here, and yet another slider here. Then you will not get any better ratings for it, but you may get more satisfaction for it. You can align them in such way, I think it's horizontal, that it will fill entire cell for this layout, so to make it more aligned and prettier. So right click, horizontal alignment, fill, right click, horizontal alignment, fill. Then we need to change initial and maximum values for them. If you know something about colors, standard color schema is from 0 to 255 for each particular color for these 16 millions of different colors. So maximum for these should be 255. And initial value I think should be 0, maximum 0, not maximum but initial value 0, maximum 255, initial value 0, maximum value 255. And then we need to handle events happening for these sliders, and again here we can either go here in advanced properties in this properties list, or we can right click on it and add event handler. And here you should know something about event handling. And idea is following. For example, if you want to implement your own text editor, then usually you have to listen on key presses and key releases, because if I press and release some keys, I enter normal letters, but if I press and hold Shift key and do the same other keys here, of course it is considered that it shifts to capital letters. Similarly, if I press and hold Control key and then press and release A key, I select everything like Control A, and then I still hold Control key and press C. I copy it and then I can press and hold Control key and press P key and I paste it. So for such graphical for editors in general, your abstraction or details of events, what you need to handle is mouse movements, like I press left button for mouse and I drag it, I can select it. So you need to listen and handle for these movements: pressed key, hold key, released key, pressed mouse button, hold mouse button, mouse drag it around, etc. But if you need to calculate something, and this will not be a great example, but for example, here you have formula that this is times 100, and then I can press and release key 1 and then press and release enter, and I get this value. But also I can do something like this, Control C here and Control V here, which is something absolutely different, but behavior is absolutely the same, because for this particular calculation it doesn't need to care about how exactly I entered this value, either by Control P or just 111 or Shift 111 or whatever. Only thing it cares about what is final value when I finished my editing here. And in that case you don't need to handle particular key presses, etc. You just need to check was this value changed, and if it's changed then update it. And in our example here for these color sliders, for example, if I run it, hopefully it will run. So here I can change one of these sliders with drag and drop or with dragging mouse cursor. So I click on it, I hold left button for mouse and then I drag it and it changes. But also I can change it. See, here is my mouse cursor here, but I press right arrow key or left arrow key on my keyboard and it also changes. And so if I would decide to handle these separate events for particular mouse movements or keyboard activities, I would need to handle quite a lot of these different events, because these sliders, and then I press tab to activate another one, and again here I'm not using mouse but I'm using keyboard to change them. So I would need to handle quite a lot of different events. But because here this test area color is something like calculation for our Excel spreadsheet, we don't need to care how exactly this color slider was actually changed, either with mouse or with keyboard or whatever. What we actually care about is what is value for this slider, and if it's changed, then we need to take this value and do something about this. So that is proper aggregation level and proper abstraction level for handling these events. And when we look here, so everything which is about key and mouse motion, etc., it is wrong for us. That's not what we need to change here. What we actually need to do is just listen on change. If it's changed, we need to change color for this test area background. And that's what we need to handle. And when we say add event handler or change, we see something like this. And again here, if we will look on Java dots, it is interface. And usually, if you do not have this body for your interface, you are not allowed to construct this reference using constructor of interface. But what you are doing here, it is funny syntax for Java, that you create an referenced object, and by unreferenced I mean you set this reference to this change listener, but you do not have direct variable which you can use to refer to it later. And then you immediately implement it inside this part of body of this interface, and you have to implement method state changed. And here is your change event if you need one. And here we will first debug it a little bit, and we will do something like this. We will just check that this is what we want to get out of this slider. And when we run it, here in console, I think that is what we need. So when change, and we can do it either by keyboard, either by mouse, and when value is changed, this event handler is executed. So that means we are in right direction. So similarly, we can also add event handlers for other these elements as well. Change. And for third element also. As usual, such editors are not well suited for small screen resolution. And so handlers are created for me, and I have need to implement them. And do we have any hints here? If we don't have, then we do exploratory development, we explore it, but we will do something like this, what we usually do with objects. So first we can check what this object is. Test area is this variable txt test, and we can do something like some setter, and because it's background color, something like this. And here we need new color with particular values, red, green, blue, red, and this is slider probably. Okay, first we will implement something working, and then we optimize it. So here we can say something like slider get value, so it would be for red color, but for green color we don't change anything. Get green. Let's break it up. Red, green, and blue. And we can test it. And it doesn't work. And it ends up with null pointer exception here in this place. Why? Because of my code generator. Here, if I look on references on txt test, it's actually created in line 99, initialized or constructed. But I'm referring to it in line 73, so it is not created yet. So what can we do? We will reorganize this code by ourselves. We will initialize it before these sliders. Yeah, somebody says that we can say, here about sliders, I will talk about this later. When you create such an referenced object, which in this case is implementation of change listener, then you can refer to other objects only if they are living outside scope of this particular method. And for example, if I will say like slider 1 here, I get compilation error because the slider 1 is not visible inside this unnamed change listener. And I will show you later how can you deal with this when we will optimize our code. But and in general that means instead of these local variables we need to put them as a variables living outside particular method. So if you want to do this immediately, then we need to refactor our code a little bit again, and we need to expose these sliders and make these life, or how it's called, let's say lifeline bigger than here in this initialize method only. So what do? First, let's refactor this to red slider. Then refactor it to and so now these are still local variables. You cannot refer to them like here. Because, for example, if you do this, it's blue, it's not, so you refer to that one. So this may live outside particular method, also outside this particular method, which is the implementation of this state changed event. So what we need to do to use these sliders, other sliders here in this, we expose them or make them lifeline longer, that these are not local variables, but these are variables belonging to our color slider object, what we are creating here. So now when I remove this type here, you see it changed from brown to blue, so it changed from local variable to variable belonging here inside structure of an object. And similarly here, I actually do not declare new local variable, but I use this variable here. And similarly for blue slider. And then we can do this in different way. We can say red, green, slider, get value, and now we have another problem with initialization of sliders themselves. So all these should be before event listeners. So we need to reorganize them a little bit, let's say. So we need to do something like this. Okay, I will put them currently here. Red slider, listener, green slider, listener, and there is blue. So first I create them and set them up, and only then I add listeners, because here I'm referring to other sliders as well. And now something even works for one color, and then similarly and I don't need this debugging here anymore. We can do something similar here and something similar here, and then of course we see that we have created not only duplicated, we have created triplicated code, and looks like it's working, except initial color is not black, or so how can we optimize it now? We can optimize it in following ways. All this duplicated code actually should be put somewhere else, like set background color. And here our to-do says that actually we can put all these listeners somewhere here, and we call set background color from them. And then we need to set it to black. Maybe it will work, because these color sliders should be set to 0 initially. And we can check does it still works for forward reverse engineering. Sometimes, at least in older times, when I just started using this window builder plugin, it got confused sometimes if you did too many things by your hand. And let's test it. I did quite a lot of changes, and as far as I can tell, it works. And design is also not very insane, because we do not have duplications or triplications in this case, and it looks pretty sane. Well, maybe we can add, yeah. So in general, I'm not using such approach when I'm working in full screen mode in larger screen resolution, but here for you to see, this is, because I rely on automated formatting, this is approach how I make forced line breaks for automatically formatted code. So now about test automation. If manual tests are passing, we need to know how this is tested, and it is tested with color slider GUI test, which uses another framework called AssertJ, and you can learn about this framework in this mentioned URL. And how does it work? It works in a following way, that it searches for, so when you have object inside object inside object, you have this, let's say, aggregation path, how you reach for particular object. And so this framework can be used to search particular type of object, this particular property, and this particular property is name of this object. And do not confuse name of object with name of variable. Every time you select some object here, one of things you can add various advanced properties. Here, there is also a property called name, and it is name of variable. It is name what you set for this particular object, and here is the generated code. Similarly, as you can set value, set maximum, etc., you can also set name for this particular graphical object. And this framework searches for particular type of object like text box or slider with particular name properties of them. And if it's only one, I think you maybe are not required to mention name, but if you have similar types, this name is used as unique key to identify this particular object which should be used. So on here we need to say that name is red slider, for this slider, for green slider it is green, and for blue slider it is blue. And then it searches for a particular object with particular name property, and then invokes it, like change its value to this or that and something else. And when it is done, we can try to run it. Something didn't work well for me. Name red slider, strange. Component hierarchy. So it says for some reason it says only blue slider. That's interesting. So that's what happened. And here the pattern matching of course helps. So red, red, red. Yeah. So that's our problem, I think. At least. Oh yeah, again. Sorry. It's just too early morning. Yeah, thank you very much. And of course that's a problem between display and keyboard. And now it even works. So again, this these tests for web applications and GUI applications are shown as open sourced intentionally because you may use them as hints and templates for your teamwork when you also will need to do testing and test automation. But that's not all, because when you create Java GUI applications, you also need to learn how to package them, because it is quite stupid that you have to run them inside Eclipse. It's still quite stupid if you have to run them inside your Eclipse or Maven project. Like here, Java, class path is target classes, and then GTM, activity 16 color. And it even doesn't work here from command line because it doesn't find out MIG layout, and MIG layout is not part of Java standard runtime. So if you will search for referenced libraries in the project, somewhere here you will find this particular jar file, which is used to make this application nicer in this particular layout. Of course, you can do this layout in different way. So, and therefore, you should also learn how to package Java applications to make them just a runnable jar file. And of course, for modern IDEs, creating runnable package is one of their features, particularly for Eclipse. You have to run this application at least once, because you have to create this run configuration, and then in this color slider like configuration you say that class where you will start your public static void main method is this class, and then you have all these dependencies here, etc. And when you have created this run configuration, you just say file, export, runnable jar file, launch configuration is your color slider, destination, it is in your workspace in this package, src, main java, gtm, activity 16, how this jar file should be called, color slider with dash. Color slider jar, and save it. And package required libraries into generated jar. And I do not know exact difference between extract required libraries. It looks like it is puts them as a class file, and here it puts them as a jar file, I think. And wait, here, because our project is full of warnings, we see here that there are these compile warnings, but we agree about them, and we are done. So here is our color slider jar, and color slider jar is executed with java -jar and this jar file, and here it is. Only problem is that when we relied on these configuration settings of our project, because Eclipse knows it's Maven project, it included all dependencies not needed for this particular color slider, but it packaged everything on which our project depends. So reference libraries, here you see approximately 150 libraries, and everything of that is packaged into this jar file. And if we look, and you should know that var and jar files are just zip archives with proper folder structure. And if you open it with Archive Manager, you see that all these libraries are included. Also for other activities as well. So it's quite insane. And you see that our small color slider size is 53 megabytes. So, and if we will run another JUnit test, which tries to run this jar file, which I have created, color slider test suite. So first it runs as a Java class, and second it runs as a jar file, and we see that size of slider is too big. So what a maximum is allowed for us is 400 kilobytes, not 56 megabytes. And so here challenge is to clean it up, because one of options actually may be quite easy is following. If you use particularly Eclipse, you can create new Java project, and you copy this class into separated project. Copy this class and paste it into that project. And then of course it still should be in GTM package blah blah blah. So actually it needs to be moved in refactor move in create package GTM activity16. So I'm doing this first time, something may not be working well. This is now Eclipse project, not Maven project, and we need to add this jar file by ourselves. Maybe we can download it from Maven repository manually. Maybe this entire package. Okay, what can we do? We will also copy this required library. So where is referenced libraries? How can we sort it by class path? We will do it following. why it doesn't show up. So this jar is what is needed, miglājot. Where is this one? Let's copy it. Let's create new proper folder like lib. And let's paste it here. Okay, then we will copy it from our repository. So it is net. Strange. Where then it is located. Oh. Here it's net, but here it's Tom. That's something interesting. So on here we will put it on our test project. No, not test project, color slider lib. And then we need to add it into class path of our project. Build path, add to build path. Let's run it. And we have created our run configuration. And that means now we can extract it or export it as executable jar file using this run configuration as a settings. I'll export runnable jar file. How this run configuration is called. Yeah, color slider 1. I think dependencies only miglājot. Yeah. So file, export, runnable jar file. Not this color slider, but this color slider. Place. Let's first put inside that project. Let's say here. Actually not here, but color slider GTM activity 16 here. And finish. So it works, and size for it is 196 kilobytes. So this is one way how can you do Another way, how can you do this inside particular project? Okay, we can copy it as a work in progress from this project to that project. Yes, I want to override this with that. And if we will try to run JUnit test or slider test suite. Now everything is passing, and that is great. So this is one way how to do this. Other way is to remove all these dependencies what we have generated using Eclipse. And when you extract something in Eclipse, and again in IntelliJ IDE it may be details, I think may be completely different. So we export runnable jar file. Our run configuration is this one. Our target will be here. But what I will actually do here is, because previously, many years ago, I have worked with Ant package management and dependency management tool, which is more old school. Ant is something like Ant to Maven is similar as Spring to Spring Boot, so it's older. You have to do much more configuration by your hand, but you can generate this as an Ant script to build this particular jar file. So here it still will build it, but we will also generate XML file with all these dependencies. Yes, I will overwrite. I'm optimist. I have better copy in other project. Out of synths. How do I go out? So is this? No, I have not changed this run configuration. This place, save it as an Ant script in my workspace, like export XML. Something is not working correctly, but I think this export XML file, is it created? No. Let's rerun this to be sure that Eclipse know what is talk about. And of course, if you are in desperation, you can clean up this archive, like using Archive Manager. but it's very error prone. For example, you can check all these and say remove from archive, and then you can check all these except this particular library MIG layout and remove them from archive, and then you can go here and you can delete everything from here except activity here. And let's save it for now. I open terminal to current window pressing F4. So it still works. And size for it now is only 466 kilobytes, which is a little bit too much. So let's edit it a little bit more. Open it with Archive Manager. What else we can remove? What is this? To do. All are these just to do's. We can remove, I think, everything here. What is here? Eclipse GDT. I think this also may be removed. So now it's only 200 kilobytes, but I deleted too much. And then, of course, because I did it not with the scripts but with my hands, I need to generate bloated jar file again and then clean up. So I was very close to make it smaller manually or clean it up. So let's try again. I don't remember about this. Do I have some notes about here, but I need to require package required libraries into generated jar. Yeah, I think this is proper one. We don't need to extract them. But what does it didn't like? I created it in workspace, not in U00. I think that was problem. And this is just warning. I will ignore that. And if I check here now, my export XML is created here, and I think my export XML is also created inside workspace. Yeah, I was not careful enough. So, and when we created such file, we can look how it looks like as Ant building script. I think I exported that other project because here already it has just MIG layout blah blah blah. Again, was not careful enough. File, export. And here you see drawbacks of color slider one. I wanted to have color slider U00. And in this location, workspace U00 export. So every time I do error in graphical interface, I have to redo quite a lot of clicks. If I do it in command line, usually it is just up key, fix some settings and redo it again much quicker. I think with this time I will get it. Right. Yeah, and now I actually exported that. And here good thing is that let's do something like this. Work in progress for activity 16. So now I can clean it up, save it, and if I do some changes I can undo it. So only thing we actually need from all this, what is described here in PomXML, or is this MIG layout library. Everything else is not needed for us, and that means we can delete dependencies. Before that, zip file set, and after that. Let's auto format it. And then Eclipse, now I don't know, maybe if it doesn't work, you should do something like sudo apt install ant. For me it's already installed, and then here in difference with Maven, it is quite easy to use. Here dot additional parameters, but we can just say ant build, and what it will do, it will create jar file here in this place with this name, so we can, let's say, I have created quite a lot of garbage with my tests. So let's remove that one, and let's run it as a ant build. And the build is successful, that is great. And if we look here, our color slider is created 272 kilobytes. Not so great as for this test project, but still below 400 kilobytes, and it works. That means here it's still some of garbage. Added here what is not needed, like Log4j properties, we don't need that. We have too many classes still here, but it's much better now. So do whatever approach you like, but if you want to get full credit for this activity, you have to package this color slider application as a sanely small archive. And if you will use something other Java applications, don't think that they are also cleaned up very well. Usually, again, these who are building and packaging these applications, they do black magic like you are doing here, because for any non-trivial project, packaging is activity on itself. And so that's another way how you can package and build it up. And of course, you can package it entirely manually. I do not recommend it, because if you do it entirely manually, what you need to have, you need to have application properties, probably. Then you need metainf subfolder with manifest.mf, which says from where you start running your application. And Then you need this class path GTM activity 16, where are your color slider class and where are your dependencies like MIG layouts 355.jar. As you see, structure for this archive is a little bit different than structure from our cleanly generated archive here. But everything should be described here in manifest.nf. This is very clean. So it says main class where you start running public static void main method is here and dependency is here. So probably if your main goal is to make a package as clean as possible, you should create a dedicated project for that and create it in a following way. So this is, in terms of size, it is most productive way. Do you have any questions or comments on that?